Okay, so factoring by grouping. I personally think that this is a fun one. And I need to remember to open this in books. Just one moment. So, um, this can feel like it's a little bit difficult. I personally don't really think it's difficult, but I'm not everybody. So, I'm going to get right to this, everyone. And if you need to, on the side, do factor trees like we were in the last lesson, feel free to do that. I'm just going to basically do the division sort of in my head as we go through this. But again, if you do need to do factor trees, please do take the time to do that if it benefits you. And so to start with, I'm just going to rewrite the expression here. And then factoring by grouping, recognize that we could rearrange these things however we wanted to, because addition is commutative. Like 3 plus 2 plus 1 is going to give me 6. And 1 plus 3 plus 2 is also going to give me 6. So I can arrange these things in whatever order I want as long as it's addition. And so one of the little tricks to factoring by grouping is trying to put things next to each other that have a lot of common factors. And so um, one thing that I would choose to do on this first one is to put the 4 next to the 12 and put the 5 next to the 15, because 4 and 12 have a lot of common factors. And 5 and 15 have 5 in common. The other thing to recognize is that if you don't choose to do this the way that I just did and you just factor it by grouping the way that it was, you will come out with the same answer that I do, assuming that you do it correctly. And so what's next for us is we're going to do this, I call it the down the middle there with that blue line. And what that is we're splitting this expression into two halves, a left half and a right half. And so we're going to factor those halves independently of each other. And so on the left half, I can see that 4 and 12 both have 4 as a common factor. And w to the power of 3 and w, the lowest one there is w. And so if I divide 4w to the power of 3 by 4w, 4 divided by 4 is 1, I would be left with w to the power of 2. And then if I divide 12w by 4w, I would be left with 3, and no w's because w divided by w is 1. And so again, that's the left side of the expression. Then for the right side, I see that they both have a 5 in common. So I could factor out a 5. What would be left would be w to the power of 2 and 3. And so now what we need to notice, and this is one thing that was kind of confusing to me when I was learning this a long time ago, is that now I have the two halves, right? My left half and my right half. And so I need to think about, gee, is there something I could factor out of both of those halves? And what we need to see is that, look, both halves, my left half and my right half, have w to the power of 2 plus 3 in them. That means that I can factor those out. And so we're going to take these two this pair of w to the power of 2 plus 3 and divide it out of both sides. So both of those are being divided out now. They're going to be on the left here. What's left is the 4w and plus 5. So what remains is 4w plus 5. And so that last piece there, this whole thing is sort of confusing for a lot of people. I hope that I'm explaining this in a way that makes some sense. And so again, the steps are: we split the expression in half, we factor the left side, we factor the right side, and most of the time we're going to end up with what's highlighted in green, where we have something on each side that is common that we can factor out or divide out, and that in this case is w to the power of 2 plus 3. And then what's left is the 4w plus 5. So they just both kind of get set in their own pairs of parentheses, and we would be multiplied by each other. And now if you wanted to check this, you could do what we did in the last lesson and multiply it out. For the sake of time, I'm not going to do that. But if you're taking a test or something, that would be a great idea, because it would help you determine whether or not you did it correctly. Okay, on to number 2. Now we have the fun of a bunch of negative numbers, which complicates it a little bit, but not too bad. And so I'm going to rewrite what we've got. We've got 2v to the power of 3 minus 3v to the power of 2 minus 14v plus 21. And so I'm looking at this and I'm like, okay, 14 and 21 both have 7 in common. 2 and 3 don't have anything in common, but if I was to flip the 3 and the 14, I would have other things in common. I could do that. I think for this one, I'm just going to leave it the way it is. So I do my da-da-da-da-da, and then I look at my left side. And again, you could flip the 14 and the 3, and you would get the same thing that I do, assuming you do it correctly from there forward. So 2v to the power of 3 and negative 3 don't have any numbers in common except for 1, but they do have a v to the power of 2 in common. So divide v to the power of 2 out, you get 2v minus 3 on the left side. And then on the right side, this is tricky because that minus sign is there. I'm going to ask you to do this, okay? Put a huge plus sign right here. We are never going to put a minus sign right here because it really complicates life and makes bad things happen. We'll deal with cleaning up the signs later if we need to. But this right here, I'm actually going to do it red. It's important. This right here is always going to be a plus sign, never a minus sign. Okay, and so on the right then, we will see that we have 7 in common. So I could factor out a 7. And then when I get negative 14v divided by 7, I get left with a negative 2v. 21 divided by 7 is 3. And so that red plus sign right there is a big deal. Always put a plus sign in the da-da-da going down the middle, and it will save you a ton of headaches. Alrighty, so now I see that on both sides, magically, again, I don't have the same thing. Look at this. I've got a negative 2v plus 3, and I've got a 2v minus 3. So they are not the same, so I can't factor them out. So we need to do a little bit of problem solving. To make the one on the right look like the one on the left, I need to take a negative 1 out. And so instead of dividing all of that by 7, we're going to divide all of that by negative 7. And that's going to cause the 2 to be positive and the 3 to be negative. So now we can see that 21 or negative 14 divided by negative 7 makes positive 2, and 21 divided by negative 7 makes negative 3. Now this and this match perfectly, so I can divide them out. And so again, just like on the last one, those are both going to go over here. And so we will have a 2v minus 3 times v to the power of 2 plus a negative 7. And this right here is not a happy time. This right here is not a happy time, so we got to do something about that. And a positive sign and a negative sign will combine to make a negative sign. So we'll clean that up. 2v minus 3 times v to the power of 2 minus 7 is going to be where we end up. And so a little bit tricky in this regard, but the minus sign on that one kind of threw me for a bit of a loop, but recognize that you might have to play with minus signs a little bit as you work through these. Okay, on to the next. So again, we've got some minus signs that are going to try to trip us up. So, and I don't know why I did that right there. Okay, so I'm going to rewrite this thing and group things together. So I see that I have a u and a y. On the first term, I have a 7 with a 2. The reality is it doesn't matter if I regroup these so I have things that I can divide out. As long as I have something that I can divide out, I'm going to get the same thing. And so if I was to do this the way that it's written, I would have a uy minus 14u plus 7u to the power of 2 minus 2y. And at this point, if I did my on the left, I would be able to take out a u. On the right, I would not be able to factor out anything because there are no common factors. And that's problematic because it stops us from being able to do this. And so what we need to do is regroup this so that we have the left side has something in common that we can factor out. The right side has something in common that we can factor out. So I think what I'm going to do, and it helps me if I consider these to be individual pieces like a puzzle. Here's one piece, here's another piece, and again, remember the sign stays with the number. I can move these blocks around however I want because addition is commutative. And you might be thinking, well, I've got subtraction going on here. Yes, you do. But subtraction is really just the addition of a negative number. And so if we draw boxes around these like I just did, we can move them around freely however we want. And so I think I'm going to stick the uy together with the negative 2y, because then I'll be able to take out a y. And then I will stick the negative 14u together with the 7u to the power of 2, because then I'll be able to take out a 7u. And so again, I do my And so on the left, I can divide or factor out a y. And uy divided by y just leaves u. And 2y divided by y leaves negative 2. This next piece, always a plus sign. And then on the right side, I see that I can factor out a 7, which is going to leave negative 2u. Oops, nope, I need to take out a u as well because they both share a u. So I can take out a 7u, which is going to leave a 2, negative 2, my bad, plus u. And so let's look at this and see what we've got. Does this one, darn this thing. So does that one match that one perfectly? And the answer is no. They look really similar, and they are the same thing. I can, just like with the ones I boxed in blue, we can rearrange things because it's addition. So I need to make my one on the right look exactly like the one on the left just to help myself not have any confusion. So y times u minus 2 plus 7u times, I'm going to rewrite this as u minus 2. So again, that's equivalent to what I just had up there. And then I'm going to notice that u minus 2 is common to both of them, so that's going to get factored out. And then what's left is y plus 7u. And again, you could multiply that out to check it, and you would get the same thing that we started with. If you don't get the same thing that we started with, you made a mistake somewhere along the way. And so that's it for that one. The last one for this week, or for this assignment. We have, again, a bunch of negative signs, which is always super great. And so I'm noticing similar to the last one, I've got 4u to the power of 2 minus 9w minus uw plus 36u. If I do my down the middle, I could take a u out on the right, and there's nothing that I could factor out on the left. And so I don't like that. So I'm going to rearrange this in a way that will allow me to factor out more than that. And so I think the 9 will go well with the 36. And the uw will go well with the 4u squared. So 4u to the power of 2 minus uw minus 9w plus 36. And again, there are multiple ways you could arrange these to make it so you have something to divide out. It doesn't really matter. Again, you should get the same thing that Schlegel gets regardless of how you arrange these. And so on the left, my So on the left, I see that I do have a u in common, so u will factor out. That leaves a 4u minus w. And on the right, again, remember this is always a plus sign here. On the right, I can factor out a 9, which would leave w plus 4. This is an interesting one. So I was stuck for a moment because I was thinking, hey, this one on the left looks nothing like that one on the right. And then I realized that I made a mistake. So checking my division on the right side, negative 9w divided by 9 makes negative w. And I forgot to write the u on that 36 right there when I copied my stuff down. So there are lots of opportunities for typos with things like this, like the one that I made. Just a plug for if you do that on the test or whatever, I'm going to give you full points if you make a typo and your work looks correct. But at any rate, now we need to check and see if the thing in the left looks like the thing in the right. Oops. And it's pretty close, but again, I'd like to rearrange what's on the right to make it exactly match what's on the left. So u times 4u minus w plus 9 times 4u minus w. I can rearrange those, right? The negative w and the 4u. So now they look exactly the same. They are going to be divided or factored out to over here. And we will get 4u minus w times u plus 9. Alrighty, and that's going to be it for number 4. And for homework 8, that is the end of this homework assignment. I hope this is helpful, and I hope you have an awesome day.